The LOH-jit function is the inverse of the sigmoidal logistic function or logistic transform used in mathematics, especially in statistics. When the function's parameter represents a probability p, the LOH-jit function gives the log odds, or the logarithm of the odds p/1p. Definition: the LOH-jit of a number p between 0 and 1 is given by the formula. The base of the logarithm function used is of little importance in the present article, as long as it is greater than 1, but the natural logarithm with base e is the one most often used. The logistic function of any number is given by the inverse LOH-jit. If p is a probability, then p/1ap is the corresponding odds. The LOH-jit of the probability is the logarithm of the odds. Similarly, the difference between the LOH-jits of two probabilities is the logarithm of the odds ratio, thus providing a shorthand for writing the correct combination of odds ratios only by adding and subtracting. History: log odds was used extensively by Charles Sanders Park. The LOH-jit model was introduced by Joseph Berkson in 1944, who coined the term. The term was borrowed by analogy from the very similar probit model developed by Chester Itner Bliss in 1934. G. A. Barnard in 1949 coined the commonly used term log odds. The log odds of an event is the LOH-jit of the probability of the event. Uses and properties: the LOH-jit in logistic regression is a special case of a link function in a generalized linear model. It is the canonical link function for the Bernoulli distribution. The LOH-jit function is the negative or the derivative of the binary entropy function. The LOH-jit is also central to the probabilistic Rasch model for measurement, which has applications in psychological and educational assessment, among other areas. The inverse LOH-jit function is also sometimes referred to as the ʻloʊdʒɪt function. In plant disease epidemiology, the LOH-jit is used to fit the data to a logistic model. With the Gompertz and monomolecular models, all three are known as Richard's family models. Comparison with probit. Closely related to the LOH-jit function are the probit function and probit model. The LOH-jit and probit are both sigmoid functions with a domain between 0 and 1, which makes them both quantile functions, that is, inverses of the cumulative distribution function of a probability distribution. In fact, the LOH-jit is the quantile function of the logistic distribution, while the probit is the quantile function of the normal distribution. The probit function is denoted, whereas the CDF of the normal distribution, as just mentioned. As shown in the graph, the LOH-jit and probit functions are extremely similar, particularly when the probit function is scaled so that its slope at y=0 matches the slope of the LOH-jit. As a result, probit models are sometimes used in place of LOH-jit models because for certain applications the implementation is easier. See also, discrete choice on binary LOH-jit, multinomial LOH-jit, conditional LOH-jit, nested LOH-jit, mixed LOH-jit, exploded LOH-jit, and ordered LOH-jit, limited dependent variable. Daniel McFadden, a Nobel Prize in Economics winner for development of a particular LOH-jit model used in economics, LOH-jit analysis in marketing, multinomial LOH-jit, perceptron, probit, another function with the same domain and range as the LOH-jit, Reddit scoring, data transformation, references. Further reading: Ashton, Winifred D. The LOH-jit transformation, with special reference to its uses in BIOS A. Griffin Statistical Monographs and Courses 32. Charles Griffin. ISBN A0-85264-212-1A.